This video will cover unknown angles. The first part, we're just going to start with some important information that we have to know going into some of these problems that have been on Common Core exams. So we're going to start with parallelogram properties. The first property of a parallelogram is the fact that opposite sides are congruent. So as you can see, EF is congruent to DG, and FG is congruent to ED. Another fact is that those opposite sides are also parallel. If you're not familiar with that symbol, go ahead and write out the word parallel. This just means they'll never intersect, they're never going to touch each other. They are parallel like this to one another. Additionally, opposite angles are congruent. So this would be saying angle E is congruent to angle G. And also D is congruent to F. Diagonals bisect each other. And you can see that from the markings over here on the picture. This diagonal DF was cut in half. Each piece of it, DP and FP, are congruent to one another, and same with the other diagonal. Lastly, adjacent angles are equal to 180. So this is like the measure of angle E plus measure of angle D, because they're adjacent, they're next to each other, equals 180. Next we have vertical angles, angles on a line, angles in a triangle, and angles in a quadrilateral. So these first two, vertical angles and angles on a line, are demonstrated in the picture to the right. Vertical angles are congruent. So this would be like angle 2 and 4. So if angle 2 is 40 degrees, so is angle 4. Then we have the fact that angles on a line are supplementary. Meaning they equal 180. So angles 2 and 3 on a straight line should add up to 180. So 180 take away 40 leaves me with 140 for angle 3. But angle 3 is vertical with angle 1, it's opposite of it, so angle 1 is also 140. The next fact we have is that angles in a triangle sum to 180. Angles in a quadrilateral sum to 360. A quadrilateral, in case you forgot, is a four-sided figure. This could be something like a square, a rectangle, a rhombus, a parallelogram like we saw above. Any four-sided figure has four angles that always add to 360. Next, we're going to talk about triangle types. There are three different types of triangles that we often refer to. One is isosceles, where it has two congruent sides and angles, so a picture of isosceles would look something like this, where those two sides are congruent and the base angles opposite the sides are also congruent. An equilateral triangle has three congruent sides and three congruent angles. And then a scalene triangle has no congruent sides nor congruent angles. So something like this, where all angles are different, all sides are different. Lastly, for this important information, we have parallel lines. They form several different types of angles, such as alternate interior, alternate exterior, corresponding, same side interior, or same side exterior. The first three pairs of angles all end up being congruent. So parallel lines form congruent alternate interior angles, congruent alternate exterior angles, and congruent corresponding angles. Now, alternate interior angles are always formed out of the letter Z. It could be a forward Z or it could be a backward Z, but that's just a trick to help you find them. So this would be something like angle 3 and 4. Not 3 and 4. What am I saying? 3, find my Z, 3 and 6. Ooh, there we go. Then alternate exterior angles are angles like angle 1 and then angle 8. Corresponding angles match up. They're in the same position. So something like angle 1 and angle 5. And again, these three pairs are all congruent to one another. However, when we talk about same side interior or same side exterior, like angles 3 and 5 right here, they are equal to 180. Or in other words, they're supplementary. And you can kind of think about that in terms of that parallelogram we had earlier. say angle 3 and 5 are here, these two adjacent angles add to 180. This first question comes from a Common Core exam in geometry. It says that Joe drew line segments ABC, D, EFG, BF, and CD as shown in the diagram below. Scaling triangle BFC is formed, so that tells us right away that none of the angles are congruent, none of the sides are congruent. And it's asking us which statement will allow Joe to prove that the lines up here, ABCD and EFG, are parallel. So here we always start by looking for a Z, because again, those are your alternate interior angles that would then therefore be congruent. So here, if I just kind of outline this huge, gigantic Z, maybe those are some angles that are congruent. Now we could also be looking at a different Z. We can go backwards, remember, it's not the end all be all. If there's not one forwards, there might be one backwards. But we're going to focus first on the one that I originally highlighted here in purple. Okay, so here I'm looking at angle BCF and angle GFC. So if I see anything like this, or maybe in reverse order, FCB, CFG, then I've got my answer. So the first one says ABF, that's way out here. Okay, that's a possibility. And BFC, B to F to C. That's right here. Those two are certainly not congruent, nor do they make this Z for us. So 1 is not our choice. Number 2 says angle CFG. Wait a second, CFG, that was here. And FCB, that was our other angle. If those two angles are congruent, then certainly, in fact, the lines are parallel. So our answer here is choice 2. Number 2, another Common Core question. Most of these are coming from Common Core exams so that you're seeing the level of rigor in order to be successful when you retake in June. Number 2 says in the diagram below, EF intersects AB and CD at G and H respectively, and GI is drawn such that GH is congruent to IH. So I'm going to start by marking this up. Now I know immediately if two sides of any given triangle are congruent, then the base angles must also be congruent, but we'll get there in a second. It also says that the measure of angle EGB is 50 degrees, so find that angle E to G to B, right here, is 50 degrees. And the measure of angle DIG is 115, DIG. Explain why AB is parallel to CD. So we can either go for that Z look, the alternate interior angles. We could go for corresponding angles like here and say here. And it looks like it might be helpful to do that because we already have a 50-degree angle up top. So if we can find that this other angle right here is also 50 degrees, then we have ourselves some corresponding angles that are congruent. And once those corresponding angles are congruent, then we can get lines that are parallel. So we're going to start by explaining every single step as we go. Everything. So we're going to end up with several different bullets. So I'm just going to kind of make my way through this picture, marking up pieces of information as we go. So first it says that we've got 115 right here. But right next to it, they should add up to 180. So we're going to say that 180 minus 115 gives us a value of 65. So that means that this angle right here is now 65 degrees. But I just labeled it on my picture, so now I'm going to talk about it. Measure of angle GIH, name it with 3 letters there, is equal to 65 degrees because angles on a straight line equal 180. Simple as that, but we're going to make several different explanations here because remember we're working to get these lines that are parallel. But remember here that we also marked this angle congruent to this angle. So we also just found another piece of information. Angle HGI is also 65 degrees because, okay, well, here we had two sides congruent. If we think back to our important information, this type of triangle is called isosceles. Because an isosceles triangle has two congruent angles. Okay, now we're finding out more information. Remember, our goal here is to possibly find this angle, and that's kind of stuck right here in our triangle. So I've got two angles so far, 65 plus 65, which sum to a total of 130. And then if I find that third angle in this triangle here outlined in blue, GHI, we know that three angles in a triangle add to 180. So 180 take away 130 leaves me with 50. So now we just found that the measure of angle, let's see, GHI is equal to 50 because three angles in a triangle equal 180. Okay, now we just found, by looking at this picture, we just found this angle here is congruent to this angle here, 50 and 50, just like we wanted to show originally. So if we have those two congruent angles, then AB is parallel to CD because corresponding angles are congruent. So this is just one way to prove that these lines are parallel. You could have gone with finding, say, vertical angles that are congruent. If this is 50, then this is 50, which then means that the lines are again parallel because we have a Z going on here. Alternate interior angles are congruent. Again, many options, but you do have to make sure, it's very important that you make sure that you are explaining every single step that you take when you're marking up that picture. This was a 4-point question, and so essentially what they're looking for is that you have 4 pieces of important information explained in your answer. Number 3 was just a 2-point question on a Common Core exam. So this question doesn't require as much work, but we still have to explain. And so what we're going to do again is go for those bullets. If you go for bullets, then you know that you're hitting some important information here. So it says the diagram below shows parallelogram LMNO with diagonal LN, and the measure of angle N is 118, which is already labeled for you, kind of nice. And the measure of angle LNO is 22. Explain why the measure of angle NLO is 40. Now what we're going to do, instead of actually just putting a 40 right on the picture, we're going to call it X and put the X in our picture. We're going to solve for X and show that it does end up being 40 while explaining along the way. So first things first, we have a parallelogram, and we know from the important information on the front page that we found out that opposite angles in a parallelogram are congruent. So we're going to say that the measure of angle O is equal to 118 because exactly what we just said. Opposite angles in a parallelogram are congruent. Then if I take a look here, we have this triangle LNO. That triangle right there, where we have 118. Whoops, did not mean to keep that on there. We have 118, 22, and an X inside a triangle, which means that they sum to 180 degrees. 118 and 22 give us 140 plus X equals 180. So then X equals, well, subtract 140, so we're ending up with 40. Wait a second, that's what we were supposed to get. And it's exactly where we placed the X earlier. So now we're going to say that the measure of angle NLO equals 40 because 3 angles in a triangle sum to 180. Now again, there are different options for doing this, but because it was a 2-point question, what they're really looking for are 2 major points of information here that led to the answer as to why angle NLO is 40 degrees. The next 2 problems we have here, you can see, are multiple choice questions, which means that they are both just worth 2 points. Unfortunately, you cannot come up with the answer right away, which means that you have to do a little bit of work. You have to do some reading, marking up on your picture in order to get the right answer. If you just try to guess right away, you just assume that you can find answers in multiple choice immediately, then you are not going to be able to be successful on this test, because I guarantee you that none of the multiple choice questions will allow you to get an answer immediately. You have to do some work, some thinking, some math in order to get the right answer. So for number 4, it says, in the diagram of parallelogram Fred shown below, ED is extended to A, and AF is drawn such that AF is congruent to DF. Here we go again with 2 congruent sides, which then means we have 2 congruent angles. You might as well mark it up right away. As soon as you mark up those sides, mark up the angles as well. If the measure of angle R is 124, what is the measure of angle AFD? A to F to D, right here. Oops. So I'm going to call this X, and in the end, that's what we're looking for, the measure of angle X. So here again, we come back to the fact that we have a parallelogram where opposite sides and opposite angles are congruent. So if angle R is 124, that means angle D is also 124. That can kind of eliminate choice 1 for us, because you can see that angle AFD is not nearly as large as angle FDE. So 124 out of the question here. Now we come back to the fact that we have 2 angles on a straight line where they add to 180. So take 124 away from 180, and we end up with 56. So this angle here, FDA, is 56 degrees. But remember, this has 1 arc mark around it because we have 2 congruent base angles in this isosceles triangle. So that means angle A is also 56. Now we're going to focus for just a second on this triangle right here. We have X, 56, 56. And all 3 of them should sum to 180. So now we're going to just set up an equation. We're going to solve for X, and then we'll have our answer. 56 plus 56 plus X equals 180. So we have 112 plus X equals 180. Subtracting 112, we end up with X equals 68. Choice 3. Number 5 says, in parallelogram QRST shown below, diagonal TR is drawn. U and V are points on TS and QR respectively, and UV intersects TR at W. So they're just describing what's happening in this picture of the parallelogram. There's nothing to mark up yet, but they're just describing again what's occurring, what do you see, what's happening. Angle S is 60 degrees, so we're going to mark as we go. Angle SRT, S to R to T, is 83. And angle TWU is 35. So this little bitty angle right here. What is the measure of WVQ? WVQ is right here. We're going to choose to call this X. Whatever you're looking for, I often choose to call it X, because then that way, once I find X, I've got my answer. So again, we're going to use some properties of parallelograms here. Angle S is 60, so angle Q should also be 60 because opposite angles are congruent. Here, if I have SR that's parallel to QT and this diagonal is here, then that means that angle QTR right up here at the top is also 83 because of that Z here. Alternate interior angles. Okay, so now I'm looking at where the W is right here, and it looks like I have a 36 and then the W. And these 2 angles on a straight line should add to 180. I'm just realizing that that's not a 36, that is a 35. Okay, so W and 35 should add to 180, so I'm just going to take away 35, and we end up with 145. So right where the W is, I have a 145 degree angle now. And if we focus for just a second on Q, T, W, V, we actually have a four-sided figure where all four angles sum to 360. So our last step here in solving for x is to just add them up to 360. 60 plus 83 plus 145 plus x equals 360. So do a little bit of math here. Grab a calculator, plug these three numbers in, 60, 83, 145. And we end up with 288 plus x equals 360. So we're subtracting 288, and we find that x is equal to 72. That was our goal. Remember, x is our answer here. X is 72, choice 3. The last question in your notes here today says, in the diagram below, ABC is parallel to DEFG. Transversal BHE and line segment HF are drawn. If the measure of angle HFG is 130 and angle EHF is 70, what's the measure of angle ABE? So again, I'm going to choose to call this X here. This was on an old Regents question, and I believe that it was a 2-point multiple choice question. I'm not sure, I can't recall exactly. It did not require you to explain your response, but this I'm asking you to explain because this is more the way of the Common Core. So here our goal is to find x. We know that we have parallel lines. So my first step is just to work through the picture, see what we can find, mark up angles, and talk about them as we go. So the first thing I'm looking at are the two angles right next to each other on a straight line that always sum to 180. So 180 take away 130 leaves me with 50. So that means the measure of angle HFE equals 50 because angles on a straight line equal 180. Okay, my next step is to take a look at the triangle, because right now I have two angles in it and I'm looking for a third. And we know that if we take 70 and 50, those two angles add to 120. Then subtract them away from 180 because again, three angles in a triangle add to 180. So I end up with 60, which means that this angle down here at E, a measure of angle HEF equals 60 because three angles in a triangle equal 180. Then remember again that we are looking for x, which is way up top here. But we have parallel lines, and when I see parallel lines, I'm always looking for a z. I have an x and I have a 60 in the crux of that z, which means that x is 60. The measure of angle ABE is 60 because parallel lines form congruent alternate interior angles. Remember, those are the angles formed out of that z there. So that's it for your notes today. Remember, you can always go back, rewind, pause, whatever you need to do to help yourself, because now you have some practice problems to do before you take an assessment.